Welcome to Privacy Now, your go-to podcast for privacy, crypto, and AI. Each episode, we dive into the latest advancements, explore cutting-edge innovations, and bring you insights from experts shaping the future of Web3 and AI. From crypto degenerates to the ones in it for the tech, Privacy Now has got you covered.
Hey everyone, welcome to Privacy Now, the podcast where we explore the future of Web3, privacy, and decentralization. I'm your host, Mihna, and each episode I sit down with the brightest minds shaping the next generation of digital privacy. Be they developers, researchers, or innovators, but they're all building the tools of tomorrow. From blockchain security to AI ethics, from privacy-preserving tech to the future of decentralized governance, we break it all down in a way that makes sense. If you're just tuning in, we've already had some amazing conversations, so go check out the past episodes on Spotify, Apple Podcasts, and YouTube. New episodes drop regularly, so hit that subscribe button and stay informed. Today, I'm joined by James Austgen, a PhD student at Cornell Tech, specializing in blockchain security and privacy. He's also the co-author of Liquefaction, a groundbreaking approach to securely sharing and managing private keys in blockchain ecosystems. We'll discuss how this innovation could change the way we think about blockchain privacy, its potential risks, and, of course, the future of decentralized systems. We also have another special guest for this episode, and this is William Wendt, our head of ecosystem at Oasis Network. And to give you a bit of a teaser, I just want you to imagine this. What if you could rent or share your private keys without compromising security? What does this mean for DAOs, token lockups, and privacy-focused blockchains? So stay tuned as we dive into all of this and more. And I would like to start up with a warm-up question, James, and that is, what inspired you to pursue a PhD in blockchain security and privacy?
Yeah. First of all, thanks for having me. And my inspiration for studying blockchains, especially security and privacy, was I was always interested in digital cash, and there were all sorts of ways of paying for things online, but I felt that blockchains were the most democratic way of doing it. Because you have this completely open and transparent system, and that anyone can understand and write software for it. They can read the code themselves. And on the other hand, I had an interest in privacy. So public blockchains are not actually that good as digital cash systems, because anyone that you've ever transacted with, and even those that you haven't, they can all map your full transaction history, both present, past, and future, and see who you've transacted with, and also see what your balance is. So I noticed there's a little bit of a tension here between transparency and privacy in blockchains. And if you go back to the original Bitcoin white paper, Satoshi wrote a section about privacy in there. He wrote that privacy can be maintained in blockchains by, specifically Bitcoin, by keeping addresses anonymous. But the problem with that is people have gotten really good at tracing transactions. And so account-based blockchains like Ethereum and more or less also encourage persistent identities. So I kind of wanted to help relieve this tension between privacy and security in blockchains through my PhD.
I think that's one of the main things that usually get people interested about blockchain, and of course about privacy, because it's wonderful to have a decentralized system. It's wonderful to have this ledger that it's public and everyone can see what you're doing. But in the end, do you really want to make everything public? Of course, there are some things that are best kept private, and this is where privacy comes in. And I did see, based on your research and based on your past work, that you're interested in trusted execution environments. And I wanted to ask, has most of your work revolved around TEs? What about TEs interests you in the privacy space?
Yeah, and like maybe like touch on like what interests you about TEs compared to like the other privacy solutions, MPC, ZKP, FHE. Why has it mostly been on the TE side?
Yeah, so the reason it's mostly been on the TE side is purely because they are so much more efficient and practical for today. So I know there's been a ton of work in zero knowledge proofs and multi-party computation, and that's all developing really rapidly too. But at the end of the day, TEs are just so much faster than those. And they're kind of fascinating in the sense that they can act kind of like smart contracts without a blockchain. They can run some code on data and then prove to you and to basically anyone else that they were executed as you would expect them to. So that's kind of been the reason my research is focused on Ts, is that they're just so much more practical and they don't require as much overhead as the other systems. But we believe that a lot of the stuff that I've worked on could also be applied using those cryptographic solutions. But today, Ts are just doing so much better in terms of performance.
Yeah, and I think that's one of the things that my job at Oasis, I also have had to sort of educate people in the privacy space. It's just like we have the technology here today. Let's use this technology that's right today, build these solutions, and then like as the other technologies evolve or mature, like they can be incorporated or things can be moved over. But let's not stall progress just because we're waiting for these technologies to advance. I know that I guess some of your work originally on the TE space was for Oblivious RAM or ORAM. I imagine that was mostly to sort of solve some of the known leakages or possible leakages that in privacy that TEs offer, such as access pattern leakage. Can you maybe like talk us through what inspired that research, and yeah, like how that all came about to be that paper?
Yeah, sure. So this what you're referring to, like I worked on an ORAM solution, and this is actually part of an IC3 blockchain camp hackathon project led by Andrew Miller. And IC3 stands for Initiative for Cryptocurrencies and Contracts. That's a broader research initiative that my lab is part of at Cornell Tech. So anyway, this was part of a hackathon project, and Andrew had co-authored a paper that attacks privacy in TE-based blockchains based on access pattern leakage. So essentially, like when you run a blockchain inside a TE, you can't store everything in the blockchain, all the blockchain data in memory. You have to offload it to the disk somewhere, and it's offloaded encrypted, so it's not like you can look into it and read what's happening. However, because it's stored outside the TE, the operator of the TE can read and figure out exactly when things are being queried and which locations in storage are being queried. And so this is like a side channel leak of the TE-based blockchains. And what we wanted to do is we wanted to kind of resolve this access pattern leakage without breaking the TE hardware, because you could do this attack against the access patterns without breaking the TE hardware. And so we wanted to create a way of patching that without needing. Our goal was to create a private ERC20 token that was immune to this issue using an ORAM technique. And kind of the core thing is we didn't want all the blockchain nodes in the network to replicate the work of doing this ORAM technique because it's pretty expensive. So it would require a lot of gas to pay. So we kind of designed a way to offload all of the ORAM lookups off-chain, so it only had to be run on a single node. And then Oasis offers this for free, so we could do this through an off-chain call. And then later you can post the results on-chain. And kind of the result of all of this was we had this private ERC20 token that when you wanted to make a transfer, you could send it to someone else without anyone knowing who you sent it to or how much you were sending. And we were able to implement this and it ended up winning the hackathon. So it's a pretty fun project.
Yeah, absolutely. I think for me, one of the things I always talk about is like this idea of trying to get Web3 as sophisticated, or at least have the same level of possibilities when it comes to sophistication as Web 2. And so like I think about like what is the Web 2 experience? Like when you do like something like Venmo, like your friends, your family, they can't see, or like Cash App or something like that, they can't see these transactions occurring. And so I thought about like this ORAM solution is finally getting us into a place where at least if a user wants that level of sophistication, they can have it. But so
Will,
that was
sorry to interrupt you, Will. I just wanted to know one thing, because we're getting into very technical details, and our audience may not understand everything. So this is a personal curiosity as well. When you're talking about pattern leakage, basically, if you're the server owner, right, of the specific TE, what data may be leaked in a local environment? Is it based on high usage, or can you deduct which accounts made the transactions, or how exactly does it work?
Yeah, so when if you're a TE server operator, you can't see what's happening within the TE, like the computations it's doing inside there. But if the TE needs to access external storage, which it does because these blockchains are much larger than memory that the TE has access to, the operator can see all of these queries. So they can see which locations in storage are being accessed, and also when these accesses are made. And so, for instance, if you were to create kind of an ERC20 token and just copy it onto a TE-based blockchain, by default, like the server operator could see which storage locations a particular transaction was accessing. Like, for instance, if you were sending an ERC20 token to someone, the operator would be able to correlate, well, this address, it corresponds to the storage location. And then later, if you sent a transaction and then someone else sent you an ERC20 token, they would be able to see that storage location that they knew that you had sent from before is now updated in this other transfer. So basically, they were able to see, they were able to completely break the privacy by mapping storage locations to addresses, and then seeing which storage locations were accessed during future transactions.
Okay, got it. Thank you very much, Will. Sorry for interrupting you.
No, absolutely. I mean, I think that's good for the audience to hear. But yeah, all I was saying is that, this brought us to that, at least the possibility for us to have the same sophistication in terms of privacy. In fact, maybe even higher levels of sophistication in terms of privacy as we have in like our everyday life. And I just thought it was a really, really cool paper. It's the first time I ever heard or, read any of James's work. And I just got very excited for the applications in the privacy space. But that leads us to your more recent work, the liquefaction paper. It was a bit of a change up. You weren't necessarily looking for access pattern leakages, more so, pushing the boundaries of what can be done using TEs. So I'd love to know like how that switch happened, where originally your research was, more in line with like Andrew Miller, trying to solve some of these side channels and things like that, to now focusing on, new applications that can be done with TE-based blockchains. So yeah, can you maybe tell us a bit about the liquefaction paper and what inspired it?
Yeah, sure. So the inspiration for liquefaction actually started with something called a dark DAO. And this was an idea that Phil Dian, a former member of our lab and co-founder of Flashbots, he invented the idea all the way back in 2018. And a dark DAO is a DAO that's kind of designed to attack other DAOs by bribing members of the DAO to vote a certain way, and then they can get paid for it. And it relied on specialized hardware, like wallet software, that all the participants in the dark DAO would run. And even though Phil invented the idea so long ago, no one had created a private one before. They only made like a simple, like smart contract based one that didn't really have any privacy. So after having spent time on the hackathon project, we realized that it was very doable to create a dark DAO. And so we decided to go forward and do that. And after creating the dark DAO, we realized that there were the fundamental assumption that was being broken was that the person the person voting on a DAO was the same as the person who wanted that vote to happen. And we decided that there were actually all sorts of other applications for this. And so we then broadened the dark DAO into a whole wallet system that we call Liquefaction.
I just want to know, because I'm sure our listeners are not familiar with liquefaction and so forth. Those new to the concept, could you maybe explain what liquefaction is and how it works at a high level?
Yeah, absolutely. So I guess we could start with some background. So liquefaction ends up overturning fundamental assumptions about ownership in blockchains. And the one thing that it changes is that we tend to assume that each address in a blockchain has one owner. And this is reinforced all over the blockchain space. So like, for instance, whenever you create a wallet, software or hardware, you'll get some message saying, don't share your key with anybody. Keep it completely safe and private. And the reason for this is if you give your private key to someone else, well, then they can take all your money. And so even if you had some idea for maybe let's say your cousin wanted to borrow your wallet so they could play on a metaverse using maybe a metaverse character owned by your account. Well, if you gave them your private key and then your cousin could then take all your money, or his computer could get hacked, anything like that could happen. And so that's why you see all these notices saying, keep your private keys safe. This is also reinforced through decentralized identity systems that tend to tie identity to a particular blockchain address. And then even when we just look at on a blockchain explorer and we read blockchain data on there, we also tend to make this assumption. You'll often find that popular block explorers will label addresses as being owned by an entity. Like you might see on Etherscan, it labels Coinbase addresses like as Coinbase 10 or Coinbase 14. And so by reading the blockchain, we tend to assume, that address is owned by Coinbase and not by anyone else. And this kind of extends to secrets in general. We're constantly told, keep your password secret, don't share your two-factor authentication codes, etc. And I mean, the reason for this is obvious. On blockchains, you don't want to have your money stolen. But the thing about liquefaction is it's a wallet system with programmable access built in that breaks this assumption about ownership. So at a high level, it means that you can now create an account that you can actually share with others with restrictions. So instead of giving someone like your cousin full control, you can hand over very specific permissions for your blockchain account to them. So maybe in the case of your cousin wanting to play on the metaverse using your character, you give your cousin only access to signing messages authorizing logging into the metaverse, and you don't give the cousin access to your funds. And you can do this with liquefaction. But there's also another thing that you can do with the liquefaction wallet system that doesn't necessarily just involve sharing. You can actually lock yourself out of signing particular messages or transactions and instead give someone else exclusive access to doing that. So that's kind of where the name liquefaction comes in. You can actually liquefy assets, blockchain assets that controlled by your account that previously you couldn't without support from the asset itself. Like for instance, with DAO votes, DAOs tend to use tokens as their voting protocol, and how many votes you get is associated with how many DAO tokens you have. And currently, the way it works is when you want to vote in a DAO, it will check how many tokens you have and then give you that voting power. But the voting power that you get is coupled to the amount of DAO tokens you have in your account. And so basically Liquefaction can split the DAO votes from the underlying DAO tokens and create two separate assets. You can sell access to signing these DAO votes to someone else and lock yourself out of that, even on your own account, while still retaining the DAO tokens and not letting that other person that you've delegated signing access to spend your DAO tokens. And the last interesting thing about Liquefaction I want to go over right now is that none of this requires any built-in support from the applications you're targeting. So it doesn't need to be implemented by the metaverse to create this delegation system, although maybe they might want to do that as a feature, but it doesn't require anything built in to happen. And so it can be done entirely privately, because on the systems you're targeting, like blockchains, for instance, you don't have to create an extra transaction to do this delegation. This is happening off-chain and controlled by the wallet itself.
Okay, this sounds really interesting, because initially I thought of it as and this might be a stupid way of thinking about it, like a multi-sig wallet with customizable permissions, basically, that you would have an admin and customizable accounts. But yeah, this is mind-blowing. But as you were publishing the paper, was there an aha moment where you realized Liquefaction could have a super major impact?
Yeah, so it was back when we were only considering dark DAOs, and we kept coming across projects that, we were like, oh, they're making this assumption we could break this with the dark DAO. And we kept coming across these examples of like, wow, this could be impacted by dark DAOs and so on. And so then we decided, well, we should really expand the concept to cover all of these applications, because people need to be aware of this. Like, that all these systems could have this assumption about ownership that can easily be broken today using TEEs, and especially TE-based blockchains. And that's actually really easy to do that. So we wanted to make the community aware. And I think it was when we were doing the dark DAOs and identifying all these other places they could possibly impact that we realized it could have really big impact on the blockchain ecosystem.
Yeah, for sure. I mean, I think in blockchain we see this pretty often, like where we see something that doesn't really exist, I guess, anywhere outside blockchain, where it be like flash loans or the idea of like MEV. We keep realizing that there are these sort of unexplored areas, but at the same time, a lot of those can also have positive benefits as well. So I know like dark DAOs were like, sort of an exploit on, DAO voting, at least the way it exists today. But I'd love to know more. Are there any breakthroughs that you think that are like positive in the crypto space, where these can help, enhance what users are capable of doing, or, building new applications or things of that nature?
Absolutely. So we, in our Liquefaction paper, we have a table toward the end of it. I actually encourage everyone to look at it. It really briefly summarizes kind of all of the applications that we've explored that Liquefaction can do. And we've come up with like pro-social and anti-social applications to all of them. And so some things that you can do using Liquefaction that really helps the community out with privacy is private fundraising. So there was a DAO called Constitution DAO a couple years ago that had been raising money to buy an original copy of the Constitution. I think there are only like maybe like 12 or 15 of them in the world. And so they had created a DAO to raise money for purchasing this. And what happened was they got narrowly outbid at auction by this big investor. And kind of what people have been speculating is that because the Constitution DAO's fundraising was completely public and everyone could see what the balance of the DAO was, that kind of enabled them to be outbid, because they already knew what the max limit of this DAO was in the bidding war. And so with Liquefaction, you can actually do fundraising completely privately without funds even leaving the people's wallets that want to contribute. So this is not even making a single like on-chain transaction. Of course, the transactions would happen on the blockchain where liquefaction lies, but if it's a privacy-based TE1, you can do that privately. And then there's other like benefits to liquefaction, like for instance, you can it can kind of be used to unify different blockchains because it's almost like a universal bridge. It's happening at the wallet level, and so you can kind of do these cross-chain transactions that are a lot cheaper than maybe using a smart contract-based bridge. And then you can also kind of settle transactions later and just use liquefaction as a way to do the accounting. So like a liquefaction wallet might only need to pay for a single Ethereum transaction, for instance, whereas if you wanted to create a smart contract and do a bridge transaction, that might involve 3+ transactions for that.
Right, and is the idea there that the sort of accounting can be done on the smart contract, the confidential smart contract side, and so like you don't need to take as many steps on Ethereum. Just you have to take that just one final step if like multiple steps were actually involved. Is that a rough idea of how?
Yeah, that's right. So like the final settlement might take place on Ethereum, but kind of the intermediate like coordination would happen on within the liquefaction wallet on the TE-based blockchain.
Yeah, that's really cool. And I think, I think it also, I guess, has broader applications for like modular blockchains, which is like, or modular applications. So like one of the things I used to think like about in 2021 is that like, the modular blockchain sort of narrative got very popular with this idea that like blockchains that have like one layer for sort of finality and one other layer for like the application, sort of the ETH 2.0 idea where you have the beacon chain and then you have on top of it, different rollups, Arbitrum, Optimism, stuff like that. And I started thinking like, yeah, I think the future of Web3 is probably like not only just modular blockchains, but modular applications. So maybe you have, Uber or something, right? And like your confidential messaging and confidential payments, sort of aspects happen on, a privacy-based blockchain. Your more arbitrary, cheap computation happens like on Arbitrum, and then your final settlement happens on Ethereum or something like that. I think liquefaction could play a big role in these sort of ideas as well.
Yeah, I think so. Especially when, as I mentioned earlier, with the ORAM project, doing like the T kind of helps you do kind of maybe some heavy computation off chain, and then you can basically publish a short proof that it was done on chain on this T-based blockchain. So I think even with that, it might have a lot of benefits in terms of transaction fee amounts. It might be reduced that way, for instance. And this could enable way more complex interactions that maybe are made simpler using liquefaction.
Very cool. And I know the paper just recently got published in December. So generally there's a bit of a lag time before that can be applied to actual applications. But in my head, like it can't come soon enough. I can't wait to see some of these more these novel ideas start being explored and innovation occurring. I actually think I think that one of the things about this cycle has been like I haven't seen as much innovation as I saw in like DeFi summer of 2020 and stuff like that. So I'm excited to see potentially this be one of the tailwinds to a next leg of innovation in Web3.
Yeah, certainly it's really exciting. I know people working on Web 2 encumbrance also. Andrew Miller's kind of at the forefront of that. And so they're looking at encumbering Web 2 accounts like your Twitter account. So you'd be able to sell like access to, or be able to sell the ability to send a message on X from someone else's account, for instance. They've created a project about that. And encumbrance, by the way, that's the term that we use for talking about restricting access to like particular portions of your account and being able to sell them through that. But yeah, it's very exciting. And I think we're only kind of at the beginning. There's going to be people that actually start building out applications around this. And we've kind of we're kind of trying to be the messenger and spreading the word that it's possible to do.
Right. And when you say the Andrew Miller stuff, that's like Flashbots and Fallow, they have that, you can basically control an AI agent that handles a Twitter account, and you can maybe pay for one tweet or something along those lines, right? So this is taking that same idea or a similar idea of like, as you say, like access controls or encumbered wallet or an encumbered account, but exploring how it can be applied more to Web3 than the Web2 side. Is that correct?
Yeah, so we actually started with the Web3 side because with blockchains, you get really strong guarantees. You get basically if you do the delegation, then you know for certain that you can do this action because you can verify the smart contract associated with that action will let you do it. And that the private key is like the sole way of authenticating to your blockchain account. But with Web2 and other ones, there's all sorts of things they have to get past, like two-factor authentication and password resets that might kind of reduce the assurance you would get around the encumbrance in those platforms. So yeah, personally, I think Web3 is kind of the more interesting one because you get really strong guarantees that in doing this action with your Liquefaction wallet, you'll get access to this part of the account and so on.
Yeah, for sure. I agree 100%. I mean, at least in the Web3 space, I'm more interested on the Web3 side. But yeah, I think I imagine at some point that both Web2 and Web3 will converge as well. Like as we see both sides sort of explore what can be done. I imagine we'll get some pretty interesting Web2, Web3 like combination applications, which also I think is great for the space for the Web3 to be merged more with Web2.
Yeah, for sure.
You already have a merger wheel with the Trump coin. I'm joking. This is what the world has come to, the major innovation. We have meme coins nowadays. So no, but it is refreshing to see people put in so much time into research and making good use of this technology. But I'm always interested in the dark side of things. Do you think there are risks or vulnerabilities associated with liquefaction? Like, do you think it could be misused in this space?
Yeah, so I think the risks are twofold. There's risks to the liquefaction wallets themselves, and then there's also risks to applications that have assumptions about ownership or identity. So regarding the risks to liquefaction wallets themselves, like the security of your key now depends entirely on the security of this TE blockchain that it's running on. So if the blockchain's compromised, then your keys can be leaked and all your assets taken from you. And this is kind of made worse by the fact that privacy is something that TEs today are not really as good at because of side channel attacks. And then it also depends on the liveness of the TE blockchain. So if the TE blockchain goes down, then you lose access to your key there. So that's also a big risk. And then going over the risks to applications that have the ownership and identity requirements. Now applications that have logic based on those assumptions are going to have to change because that assumption is going to be broken by liquefaction and people will be taking advantage of it, as I foresee.
Yeah, but if you think about it, like this is a general worldwide problem, right? Because if the server goes down, your website goes down. If ChatGPT goes down, all the agents go down. Like it's all localized in the end. So
yeah, that's true. It is slightly different though, because I know in the blockchain space, like blockchains were made to be like available forever basically, and they have all these like really strong built-in protections against going offline. So people, I guess, would have to warm to the fact that they have their key in this other system, which I guess like people are kind of already used to for other places outside of blockchain, like their bank account, for instance.
Yeah. I mean, I think the goal is for, us as an industry to get to a place where at least the liveness is not ever like truly a concern, or a very minimized concern, especially if we build applications on this. But in terms of, I guess, the key manager risks, as well as the single owner, entity assumptions, are there ways to mitigate these risks, in your opinion? I know Ari published a paper on like complete knowledge recently. Is that like a solution for this, assuming that one person owns the private key type issue?
Yeah. So I'll first go over the risks of the liquefaction wallets. So about like liveness and so on. We actually did design a way to account for liveness in the paper, and so we kind of designed this system that works even if the liveness of the T-based blockchain is gone. We have like some way of recovering it through like a separate committee of T nodes. So we do have a solution for liveness. And as for the security of the Ts, we like that's also kind of a risk right now. But I think in the long term, like stronger Ts are being developed, and it's possible that we'll eventually have more secure ones that are a lot more difficult to break, and then also designed in a way that's more trusted than currently. But when it comes to like the applications that have these ownership and identity assumptions, as you mentioned, we published a paper called Complete Knowledge that acts as a viable countermeasure to liquefaction, and specifically the bad uses of liquefaction that would break those assumptions that applications don't want to have. And kind of the thing behind Complete Knowledge is proofs of complete knowledge. And you can't create a valid proof of complete knowledge from within a trusted execution environment or from within an MPC protocol or anything like that. You have to have full access to the private key. And it does this by relying on specialized hardware like a Bitcoin mining ASIC or a trusted execution environment itself. And so the way that this can help resolve kind of the bad parts of liquefaction, like the negative use cases, is that applications can now require proofs of complete knowledge if they want to ensure that the keys they're servicing haven't been encumbered in any way. And so they can just ask for, supply this proof of complete knowledge, or, show evidence that your account has undergone this proof before, and then you can now access our application because we know you're not selling access to someone else or something like that. And kind of the underlying assumption is that if someone has seen the entire private key, they can always undercut anyone that they're trying to sell their rent access to portions of their wallet to. So for instance, if I had a proof of complete knowledge and I had seen my entire key before, and then I try to rent out DAO votes to someone else, well, then I can always sign a DAO vote that overrides the vote that I already that someone else signed on my account, because I have access to the full key. And so I can always sign things regardless of what T I try to put the private key in now.
Awesome. I have two follow-up questions to that, though. One, I guess, is the paper on complete knowledge came, well before, the liquefaction paper. So is that like the case where like the solution was thought of before the problem was discovered, or is there a different problem you were trying to solve with complete knowledge, or maybe I'm just misremembering the timelines? And then my second question is, how do you see like sort of this? Do you think that complete knowledge has this ability to, basically disable the downsides but keep all the upsides that liquefaction has possible, or does it sort of remove both at the same time?
Yeah, so the complete knowledge paper did come out before liquefaction. And so it's good that we already kind of had a solution to the downsides of liquefaction before it even came about. But the idea behind complete knowledge was the same. So we're already kind of envisioning these TE-based encumbrance systems beforehand. But no one had actually built one out or anything. So it was kind of theoretical when we were designing it. And the complete knowledge paper was actually a really long paper. I think people had been working on it for over 5 years, and I kind of came on toward the very end and built out a complete knowledge prover application. That was my main contribution. But yeah, so complete knowledge came first, which is great because we came in with liquefaction, but also had a solution for it already built out. And then I do think that it will resolve the like downsides. I think this is going to actually depend on the applications themselves as to like making the trade-off. Like, do I want to enable delegation using liquefaction or similar tools, which has the side effect of also enabling like selling portions of this application's properties to someone else using your account? Or do I want to guarantee that this person or someone has seen the entire private key, and so they can't do this rental of portions of the account or delegation or something? So I think it's going to be really application based, and I kind of foresee people maybe having an account that is strongly associated with identity for some of these projects that really do require that, and then maybe using a different account for applications that that they want to delegate access to. And there's all sorts of reasons that you'd want to have this liquefaction wallet. It can be used to help like monetize things without really much effort. And I can explain that in more detail kind of later, I think.
Awesome. Yeah. Thank you for that answer, James. I mean, I think I don't have any comments on it. You just wrapped it up and explained it very perfectly.
Thanks. Yeah.
One thing I did want to know is, do you think liquefaction will maybe change the way we think about private key management in the long term, and maybe make privacy-preserving blockchains more accessible to everyday users?
Yeah, so I think liquefaction is probably going to be heralding in a new class of applications that manage crypto assets directly from the wallet level. And because now you can actually sell portions of the key to someone else. And so I'm sure people will build all sorts of infrastructure around this. And then in terms of key management, liquefaction doesn't necessarily impact that directly, but what you can do is you can now actually sell your key to someone else and completely relinquish your own access to it, which is not something you could do before. Because previously, like if you just copy your private key and send it to someone else, well, then you still had a copy of it, and there's no way to like prove that you destroyed it unless it was generated within a T environment or through MPC or something like that. So we might see this change, like in which you can do a sort of key rotation without publishing that this happened. Basically, you can do it privately now. And then whether it can make privacy-preserving blockchain systems more accessible, I think that really depends on careful UI design, because you could also envision, I think it's basically the same issues with smart contracts, and people understanding what particular smart contracts do will also crop up in terms of liquefaction. If people are signing away access to more than they should, then they could have their assets stolen even through liquefaction. So it's going to require really careful user interface design. But I think there's also ways to clean it up so that it's very clear that you're giving this right away. And then also liquefaction can make that slightly more secure in the fact that it's kind of hierarchical. So you can make really fine-grained delegation. And maybe if you don't fully understand what this is doing with your account, like maybe if you're just a regular user and you can't read a smart contract yourself, at least you know that it's only going to have access to this particular portion of your wallet and no more. And so liquefaction helps with that.
Yeah, and if you want to see like a great iteration of like what he means by fine-grained control, if you see the paper, if you go look at the paper, it goes through like exactly the flow chart that can occur, like when it comes to like, let's say, selling a vote in a DAO or something like that, and you know how that fine-grained control exists. So I encourage everyone to go check out the paper. Even if you don't want to read the whole thing, looking at that diagram is very helpful.
Yeah, and I guess it all boils down to UX, because when it comes to Web3, I really don't think like regular users need to know what's happening behind the scenes. So this is still the issue that needs to be solved to see mass user adoption.
Yeah, I agree, for sure.
But you mentioned in the past that, of course, you guys did research on other technologies. I just wanted to know from what excites you, like what are some other trends in blockchain privacy and security that get you excited nowadays?
Yeah, so it used to be that everyone like didn't trust TEs at all. So I'm excited to see that there's some interest there, because kind of the performance you can get out of them really enables lots of applications. But the trust isn't completely there yet, and for good reason, because of all these side channel attacks. So I'm really excited by the fact that I know there's groups working on more trustless TEs that have better security and have a manufacturing process that's entirely auditable. So you can kind of trust that even the way it was created was completely secure, and that's different from TEs from Intel today, that where it's kind of more secretive exactly how they're constructed and so on. So I think with this, it might encourage more adoption of TEs and maybe increase people's trust in them. So I'm really excited about that sort of development, because it'd be nice to be able to just buy a TE yourself and run it on your own computer and have really high assurance that it's secure.
And when it comes to looking ahead in the future, where would you see liquefaction and maybe other similar technologies heading in the next 5 years? And I know this is a difficult question because nobody can predict the future, but in your own perspective.
Yeah, so I think liquefaction is definitely going to overturn that assumptions about ownership. And so you're going to start seeing like people trying to monetize their wallets, because they try to monetize everything on blockchains these days. And I can envision like a wallet that shows you a bunch of offers for letting others use your wallet for particular purposes. Like maybe there's some airdrop that you're eligible for on some chain that you're never going to use, and someone wants to bid to use your account to claim that airdrop and sell it themselves. And so I could totally see like automatic airdrop farming happening in the future using liquefaction. And then I think most of the applications that we've come up with in the paper, I think those are totally going to be implemented in the next 5 years or so. Although I think for the negative ones, I hope that applications will start using proofs of complete knowledge and other ways of preventing those. But
I have one question about that. For applications that are already built, right? Is there a way for them to implement proof of complete knowledge? Like, let's say Aave, right? Their DAO, their governance model is already pretty rigid, or it's pretty, it exists the way that it is today. Is there a way for them to integrate proof of complete knowledge into their existing frameworks? It doesn't have to be specifically Aave, but I'm just saying existing applications. Or do they basically have to migrate their smart contracts and things like that to new versions and overhaul the whole system?
Oh, that's a great question. I'm not really sure. I know like a lot of smart contracts that are deployed nowadays are upgradable. So it's possible that they have some way of doing that from within the DAO. If everything's completely fixed, it's possible that they might need to redeploy their DAO contracts. But we've actually been working on other research related to DAOs, and specifically we've released a paper recently that got accepted called voting block entropy. And voting block entropy is a metric that you can use to measure the decentralization in your DAO. And so you can use this metric to kind of get the sense of whether there's a dark DAO that's aligning everyone's votes when ordinarily you wouldn't expect that to happen. So we have tools for Aave, for instance, to measure the decentralization of their DAOs. I think for DAOs today, they're not actually decentralized enough where liquefaction would kind of cause dark DAOs to take over their DAOs. Like today, I think the top whales in DAOs can probably just get in a Telegram chat and decide which way it's going to go. But if a DAO becomes super decentralized, then that's where dark DAOs would become more of a threat.
Okay, yeah, that makes sense, and I think we've seen that in quite a few DAO votes that, as much as we want there to be decentralization, we still have a long way to go there.
Yeah.
Will, do you have any more questions regarding liquefaction? Because I would honestly I would like some personal insights from James.
Yeah, so I guess my last question before we start the wrap-up questions is yeah, I know we have a proof of concept coming. I know that it's still in the early days of development, so I'm just wondering what you feel comfortable sharing with the community, maybe a little bit of alpha, James.
Yeah, sure. So we're currently working on a demo for liquefaction, which will be publicly available. Everyone can try it out, and it will basically work on the Ethereum mainnet, and it will kind of look like something that you would not expect someone to do. You would be sent, basically you're receiving some asset on mainnet, and it completely overturns the assumptions that you have about wallet ownership because of liquefaction. And so it'll be really cool, and it will kind of enable you kind of special access if you want to try it out. So that's what I'll say about it. Yeah.
Yeah, if I could add, I'm really excited about this one, and I just like to thank James and Ari and Cornell for coming up with this idea. I think the community is going to love it, and I think, or I know, it will have broader implications on a lot of different possibilities in Web3, and so I can't wait for that to get released, and hopefully it comes pretty soon. Unfortunately, I think that's as much as we can say for right now. I don't want to go too far, James. So yeah, maybe we can move on to more of the wrap-up questions.
Sure.
Not exactly wrap-up questions. I just want some professional insights from James. And one thing I wanted to know, because as someone deeply involved in research, I want to know how do you balance the technical side with the thinking about the ethical and societal impacts of your work?
Yeah, so this is something that we're always considering when we're doing research, is kind of the impacts of it, and also the ethical and societal impacts for sure. Like that's kind of the reason we wrote this paper, was to get the word out that you can't have the single entity address ownership assumption anymore, and it's easy to work around these days. And liquefaction is very capable, both for pro-social and anti-social applications. And kind of the way we balance it is we're treating the paper as our kind of public release of the information, kind of like a what's the word for it? Kind of like when there's a security issue, that you find, you'll tell the company beforehand about it. You can't really do that in blockchains. You have to just tell everybody because these systems are open. And what we found was, like, back in the blog post, the Dark DAO blog post back in 2018, people had completely dismissed it as just like impossible. And we needed to show that it's possible today. So that's kind of the reason for creating liquefaction. And the fact that we had complete knowledge as a counterbalance to the negative effects was a big consideration we had. We didn't want to write a paper about something that would only and actually implement and publicly release the implementation for something that had no positive benefits to the blockchain community. So that was kind of how we balanced the ethics with the technical impact of the work.
That's really nice, James. Thank you for that. And one other thing I wanted to know is, what advice would you give to aspiring researchers or maybe developers looking to work on blockchain privacy?
Yeah, so actually, I think the best blockchain privacy systems are the simplest ones. And the more people that can completely understand and verify your implementation and understand how it works, the better. if there's too much complexity, then there are very few others that can participate in the project. So I think making something as simple as possible, maybe using, if you have to use cryptography, of course, use them as building blocks that people can understand. And that's really going to help get a lot of people involved.
Okay, that's a great advice. Cool. So I think we can move on to closing questions, and I have a couple of short questions prepared for the end of the episode. You don't have to go really deep into them, however you prefer. But question number one would be, can you share what's coming next for your research?
Yeah, sure. So kind of the next project will be looking at next generation blockchain wallets. So we don't think the current form of blockchain wallets is going to last forever. And so we're thinking about kind of what the next ones are going to look like a long time in the future, and maybe what properties they'll have and how they're designed. And so this might be an extension of liquefaction. It might be completely new concepts for wallets that people don't use today, because obviously they're not perfect today. People still lose their funds or get their keys stolen.
Yes, please do that as soon as possible. Okay, another question would be, what's one misconception about blockchain privacy?
So the most obvious one with that is that hiding information is always malicious or suspicious. I think it goes back to the nothing to hide argument against privacy, that if you have nothing to hide, then you should show it to everybody. But the truth is that outside of crypto, like financial information, especially on a personal level, is fairly private. So that's actually a reason why financial institutions are hesitant to enter the blockchain area, is because their trades would become public, for instance. So I think blockchain privacy is actually very necessary, and it's not always associated with people doing malicious things.
Yeah, that and like personal information and everything. Like, people really have a misconception about privacy. But yeah, I love your answer.
I have a follow up for that. I'm sorry, James.
Sure.
Bring it back to technical. But yeah, I'd love to know, like, how do you think about this? And you mentioned at the very beginning, and I never didn't get a chance to ask about it, but like this tension of privacy versus transparency. Like, how do we? It feels the community is very like biased. Like, they believe that it has to be like 0 or 1. It has to be binary, like fully transparent, fully private. How should we be thinking about privacy systems in order to, let's say, meet the needs of financial institutions and those who want things private, but also like make sure that it doesn't go into anarchism and we're allowing malicious actors to do their thing?
Yeah, so I think the one side is, obviously these privacy systems need to be transparently deployed. If there's any like doubt about whether the privacy system does what it says it does, then people are definitely not going to want to use it from the hardcore like transparency people. I think they'd probably be more interested in the transparency of the implementation than necessarily the transparency of the activity, because that's kind of already been clearly specified as having these properties or something. As for malicious users, I think eventually it will be possible to do some sort of on-chain validation, but it would require proofs of complete knowledge, for instance. Otherwise, you'd just be able to use liquefaction to say that you're someone else who's already had this their identity verified and so on, which is currently the case today.
Awesome. That's all, Will?
Yeah, I was just gonna say thank you. I mean, I think I agree with you, and I guess like the one thing I always think about as Oasis is just giving people the tools to have like flexible privacy or confidential compute. One of the ideas I always think about is like, USDC using some of these privacy preserving computation could create like a stable coin where the users have privacy from, if I send it to you, James, Minya can't see it. Like, and he can't see my balance, he can't see my wallet address. But where Coinbase could still access our, like, how much USDC we have and stuff like that. And so in this way, like, and maybe it's not Coinbase, let's say like some random entity builds this stable coin, you know, they can still be compliant in the same way that they're compliant today, where they have full auditability. But at the same time, like on the user level, we have like equal or greater privacy than we have in Web 2 today. So I think about like the flexible, like creating flexible designs like that, where you have sort of transparency and confidentiality at the same time.
Yeah, it's certainly a difficult problem. We're trying to think of similar solutions. In some ways, like a backdoor is not as satisfying. But it's hard to get around. Yeah.
But I think about that similar to I think about TEs. It might just be like what works today, and we have to, maybe accept band-aid solutions until we can come up with the better solutions. Because I think once there is a solution, like it inspires more innovation. Like I guess the worst thing to me is like nothing getting built. Feels like the industry's stifling. But when something gets built, it often inspires a better version of that thing very quickly after. I mean, even with like DEXs, we saw that. It was like the first, financial DApp Uniswap V1 came out. And then we saw, like over the course of the next year, DeFi Summer and, 3 different versions of DEXs and stuff like that. But getting to that first DEX was the problem, like getting the first thing done really was like the barrier to some of that innovation. So anyway, maybe I'm rambling, but that's how I sort of think about some of these things.
Yeah.
Okay. Question number 3 for you, James, is I want you to name a project or a person in blockchain privacy that you admire.
Oh yeah, Phil Dyan, co-founder of Flashbots and former member of our lab. He always had this like go and get it attitude, and he was not afraid of like what anyone else would think of him for doing it. So he was someone like with really strong principles or strong I messed this up. Strong opinions, that's what I meant to say. Yeah. So yeah, Phil is someone with really strong opinions and isn't afraid of what others think about him. So that's kind of cool. He wasn't intimidated by ideas, and he just went out and went for them.
I guess you have to be that way to launch something truly spectacular, right?
Yeah.
Okay, James, one book, article, or podcast you'd recommend?
Yeah, sure. This one's a little biased, but it's the one I'm reading right now. It's called The Oracle by R.E. Jules, my advisor. And what's really cool about the book is actually a key technology component in the book builds on things that are enabled by liquefaction. So it is kind of cool seeing something that you've created and published a paper on, or at least released the paper. It's going to be published hopefully soon. Gets inside a thriller novel. So that's pretty cool.
Nice. Where can we find this?
Yes, you can just search The Oracle, R.E. Jules, and you'll find it on Amazon, and you can get a hardcover copy or an ebook.
I think an ebook would work for me since I'm in Romania. And I don't think I can find it in Romania, so I'll just have to settle for the ebook version. James, where can our listeners learn more about your work?
Yeah, so if you just search blockchain liquefaction, then you'll see a link to our paper, and then probably our GitHub repository will come up. If you want to look at the GitHub page, it kind of provides a more high-level overview of liquefaction if you need a reference there too.
Nice. I'll get the links from you even better and include them in the description for the episode.
Perfect.
People can check them out. And last question is: are there any upcoming projects or papers you'd like to highlight besides what we discussed so far?
Oh yeah, well, of course, there's the demo that we're working on, which in collaboration with Oasis, which is really the project I'm focused on at the moment. Outside of liquefaction, we've kind of been monitoring other projects working on key custody, and hopefully we'll see more that are more transparent. looks like Turnkey recently released a white paper, so that's been on our radar. And they also kind of have a policy system for their key management solution. So they've kind of compared that to Liquefaction, though I think Liquefaction is a bit more flexible in terms of the policies at the moment.
Okay, and I'll follow up with another question. I don't want to sound biased, but what's the main reason you chose Oasis for?
Okay, so the reason we chose Oasis was we were looking for a TE-based blockchain that was easy to implement smart contracts on. And I had some experience with writing Ethereum smart contracts using the EVM. And Oasis Sapphire also is an EVM environment. So it actually was super easy to pick up. And so that's kind of the reason we chose it, is it was just easy to build on.
That's a very satisfactory answer. Well, James, thank you so much. It's been truly a pleasure. If you have any closing thoughts, will you the same? So,
yeah. So I think Liquefaction is probably going to make a pretty big impact on how we view ownership and identity on blockchains. And I think it's great that everyone be made aware of the fact that you can now share accounts, and you can no longer really assume that one key is associated with a particular person. That might change, and that might go to someone else. So just keep that in mind as you develop blockchain systems and protocols and applications.
perfect.
Yeah, and on my side, I guess it's just I'm excited for the work that James is doing. I think, like he said, we're gonna do some cool proof of concepts, and I think it could have very large implications for the entire Web3 industry. So I just tell the community to stay tuned, and we'll be updating you with some news pretty shortly. Besides that, on the Oasis side, our next event will be at ETH Denver. So if you're attending ETH Denver, you have any questions about Oasis, about Liquefaction, just come to the booth and come say hi. Thank you so much, Minya, for having me on the podcast, and thank you, James, for joining me.
Thanks for having me too.
It's been my pleasure, guys. And I'm super excited about what comes next. I'll keep an eye out on all socials to see all the updates. But I guess this is kind of a wrap for this episode of Privacy Now. Again, thank you, James. Thank you, Will, for joining. Everyone, if you like what you heard, be sure to subscribe on Spotify, Apple Podcasts, and YouTube so you don't miss future episodes. And of course, check out our past episodes for more insights on Web3 AI and privacy. And if you enjoy the show, share it with a friend or leave a quick review because it really helps out. And catch you in the next one. And as always, stay private and stay secure.